DHCP. Let us explore the home of the Dynamic Host Configuration Protocol, or DHCP. In any professional networking environment, DHCP is the automated registrar of the network. Without it, a network administrator would have to manually walk to every single computer, smartphone, and printer to type in a unique numeric identity by hand. This would be a logistical nightmare. DHCP handles this entire process automatically, handing out critical configurations the moment a device connects to the wire. To truly master this protocol, we must break it down into its core transport method, the four-step handshake, and the management pillars that keep a network organized. The transport, UDP. DHCP operates exclusively using the User Datagram Protocol, or UDP. It listens on port 67 for the server side, and uses port 68 on the client side. You might wonder why it uses the unreliable UDP instead of the guaranteed delivery of TCP. The answer is purely mechanical. When a brand new computer plugs into a network, it does not have an IP address yet. Without an IP address, it is mathematically impossible to establish a strict TCP three-way handshake. Therefore, the client must use rapid, connectionless UDP broadcasts to shout out into the void, hoping a server is out there listening. The heart of the protocol, the DORA process. When a device connects to the network, it follows a highly structured, four-step sequence known as the DORA process. First is discover. The client boots up and broadcasts a DHCP discover packet to the entire local network segment. It essentially yells, "I am new here and I need an identity." Second is offer. The DHCP server hears this broadcast. It checks its available pool of addresses and sends an offer packet back to the client. This offer is a complete package containing a temporary IP address, the subnet mask, the default gateway, and the DNS server addresses. Third is request. The client receives the offer and must officially claim it. It broadcasts a request packet, telling that specific server it accepts the offer, while simultaneously telling any other backup servers on the network to withdraw their competing offers. Fourth is acknowledge. The server receives the request and sends a final acknowledge packet, or ACK. This locks the lease into the server's database, tightly binding that new IP address to the client's physical hardware MAC address. Managing the network, the four pillars. Simply handing out addresses is not enough for an enterprise-grade network. An administrator must use these four concepts to maintain order. The scope. This is the consecutive range of IP addresses the server is allowed to distribute. Think of it as the pool of available identities for a specific subnet. Exclusions. These are specific addresses within your scope that the server is forbidden from giving away. You use exclusions to protect your static IPs, like your core routers and servers, ensuring a random laptop never tries to take their identity. Reservations. This is a way to ensure a specific device, like a high-volume network printer, always receives the exact same IP address every time it connects. You tie a specific IP address to the device's unique physical MAC address. Leases. Devices do not own their IP addresses. They only rent them. The lease time determines how long a client can keep an address before it must renew. This allows the server to reclaim addresses from devices that have left the network, preventing address exhaustion. Troubleshooting the 169 address. If the DHCP server is dead or a rogue firewall blocks the broadcast, the client will eventually give up. To keep its internal hardware functioning, the computer will assign itself an APIPA address. You will instantly recognize this failure because the IP address will start with 169.254. If you see a 169 address, you know the physical cable is likely fine, but the DHCP conversation has completely failed.